This lesson is about simplifying radicals of any kind, so it's not just about square roots, but I do want to start by talking about square roots because I think that's what most of us are we're all most familiar with is square roots because that's usually what we start with. So a square root is a number that, the square root of a number is a value that when it's multiplied by itself, it gives you that original number. Meaning, because I recognize that's not the most elegant definition, we know that the square root of 4 is 2. But the reason that we know that, the reason the square root of 4 is 2 is because 2 times itself, 2 times 2, gives you 4. A pair of 2's gives you 4, so the square root of 4 is 2. Likewise, the reason that we know the square root of 9 is 3 is because 3 times itself, a pair of 3's, 3 times 3, gives us 9. If you understand that, then even when we are asked to square root numbers that don't come out perfectly, we can break them down as far as we can to simplify them without needing a calculator. For example, if I asked you what the square root of 18 was, well, it doesn't come out evenly. There isn't a number that times itself. There isn't a whole number times itself that gives us 18. But what if we don't necessarily want a decimal answer from this? What if we don't necessarily want to use our calculator to find an answer for this? Well, what we can do instead is we can look to break 18 down into factors and try and find part of it that we could square root. For example, we know that 18 breaks down into 3 and 6. And 6 breaks down into 3 and 2. Well, what I notice now is that when we look at 18 when it's broken down into its prime factors, we can write this as the square root of 3 times 3 times 2, right? Just all the prime factors that we found when we broke it down. And what I noticed then, specifically, is that we've got this pair of 3's. Meaning, effectively, that's the same thing as the square root of 9, right? We just established that the way that we square root things is we're looking for pairs, essentially. So if I see a pair of 3's there, then I could pull that out as just 1 3 outside the radical with a square root of 2 left over. In other words, what we're basically saying is that 18 is the same as the square root of 9 times the square root of 2, and knowing our product property from the past lesson, we can write this as the square root of 9 times the square root of 2, and we know that the square root of 9 is 3, so 3 square root of 2 is the simplified version of the square root of 18. And you can do that with anything, right? If you know your square roots really well, then you may have noticed immediately that instead of breaking it down into 3 and 6, I could break it down into 9 and 2, and that's absolutely true. But if you didn't notice that, then instead of having to go on this long search for numbers that square root perfectly, instead, we can just break everything down to its prime factors and look for pairs if we're square rooting. So for example, let's say we wanted to do the square root of 48, which again, it does not come out perfectly. If we just know that we want to break this down to its prime factors, well then we don't have to make sure that you and I are doing the exact same thing, right? It doesn't matter how we choose to break this down. You may look at this and say, okay, I know that 48 divides by 2, so I'll break it down into 2 and 24 to begin with. But you might also notice that I know 48 divides by 3, so you break it into 3 and 16. Or maybe you break it into 4 and 12. It doesn't matter because you'll end up with the same prime factors at the end. We'll just say 3 and 16, I guess, since that's the second one that I said. We'll just go with the middle one. So if we break it down to 3 and 16, then we could have 16 break down into further things, right? 3 is prime, so we're done with that part of our factor tree. But we don't know what 16 is yet, or we don't know what its prime factors are yet, I should say. And again, you have an option. You could go 2 and 8, you could go 4 and 4. It's really up to you. I'm going to go 4 and 4. Neither of those are prime yet, so then I can break them down further. 4 breaking into 2 and 2, and again, 4 breaking into 2 and 2. And so now I've got all my prime factors, meaning that 48, the square root of 48, can also be looked at as the square root of 3 times 2 times 2 times 2 times 2. And what I'd want us to notice, is that we do have some pairs here. We've got a pair of 2's right here, and a pair of 2's right here. And since we are square rooting, and remember the definition of a square root, the square root of a number is finding a number that when multiplied by itself gives us that original number. Well, if I have a pair of 2's here, that's essentially the square root of 4, which is just 2. A 2 outside the radical. We can pull that pair. Each pair is counting for one term outside the radical. Each pair of numbers is counting for one of that number outside the radical, which means then I also have a second 2 outside the radical because I had 2 pairs of 2. Now this poor 3 doesn't have anybody to pair up with, so it's just going to have to stay inside the radical all alone. 2 times 2 is 4, so 4 square root of 3 would be the simplified version of the square root of 48. Now the reason why I like to teach simplifying radicals this way, as opposed to just using the square roots, because certainly notice, we did break it down into 3 and 16. We could have immediately just done the square root of 16 to give us 4, and we would have just had 4 square root of 3 left immediately, right? We could have done that right from the beginning. The reason why I don't necessarily have show doing it that way is because while you may know your square roots well, what I tend to find is that a lot of students do not necessarily know their higher roots, their third roots, their fourth roots, their fifth roots, on and on. They don't quite have those memorized quite as well as they may have their square roots memorized. So let's say, for example, I asked you to do the third root of 48. Well, now you have a problem, because if you don't know your third roots really well, then if you've just been breaking it down to things you know square root perfectly, that doesn't help you. But if you're just breaking it down to your prime factors, this really doesn't change a whole lot. Because the only difference between a third root and a square root is that for a square root, we're looking for pairs, because the square root is a value that multiplies by itself once, right? But a third root, we'd be looking for groups of 3, because it's a number multiplied by itself twice. Meaning, for example, the reason that the third root of 27 is 3 is because 3 times itself times itself. A trio of 3's, 3 times 3 times 3, gives us 27. And so if we think about it from that perspective, then we can break down 48 the same way we just did 3 and 16, 4 and 4, 2 and 2, 2 and 2. And this time, when we write out our prime factors, instead of looking for pairs, because it's a third root, we are now looking for trios. And certainly we do have a trio here, because we have a group of 3 2's. And so because we have 3 2's, we have that trio, we can pull a single 2 outside of the radical. And what changes then is that now we have both 1 3 and 1 2 that are left inside. So 3 times 2 would give us a third root of 6, making 2 third root of 6 the simplified version of the third root of 48. And if you do it this way, then that allows you to be able to simplify any radical I could possibly make up for you. It doesn't matter whether it's a square root or a third root, fourth root, fifth root, anything, any type of root I could think of. All you need to do is take the number I give you, break it down to its prime factors, and then simply figure out, based off the root, what group, how many of the same type of number you need. Do you need pairs? Do you need trios? Do you need a group of 4, a group of 5? It's just whatever the type of root is, that's how many of the same number you have to find to be able to pull anything outside the radical. And then it's the same process no matter what, so you don't have to feel like you're memorizing a whole bunch of different things.